my channel Self Cafe, where we make everything science, technology, engineering, and mathematics. Easy to comprehend, assimilate, fun, and entertaining. Today we are treating number basis. Number basis is about the number system, where we handle the numbers based on certain configuration, combination of numbers, and the level or extent of the numbers you can arrange together. How do I mean? The general number we use, or we are used to, is the binary or decimal system. Under this system, you have the combination of 10 figures, and every other numbers that we can derive is by combination of these figures. And what are the figures? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see. With this, any number you want to make up, it is by combination of these figures. It is by combination of these figures. And every other operations you want to carry out, you can easily carry it out with this. We are used to it. At least, that's what you have been taught. Now, there are some other number systems or number bases that we use unconsciously. Like when we are trying to talk about days and weeks. Months and years. What again? Seconds. Minutes. Minutes and hours. Hours and days. So you can see, under this system, the number base will be 7. Because how many days may come with 7? Months. The number based system is 12. Here, 60. Here, 60. And here, 24. You see? Now I told you, number under denary or decimal is combination of 1 to 9. In this place, it will be 0 to 6. In this place, it will be 0 to 11. In this place, it will be 0 to 59. Here, 0 to 59. Here, 0 to 23. You can see, the last number, we do not put here. I will tell you why. In this place, all these numbers, we want to make it easy for ourselves. We can, have one way or the other to form it. But this is how it will be. Let's now concentrate and make some kind of comparison to make the calculation under these other number systems or any other number based system very easy to handle. Now, if you look at this, let's say I want to form my numbers. I will start by writing 1, 2, 3, 4, 5, 6, 7, 8, 9. This one, I will now combine it with 0 at this point. 1, 0. You can see. Now again, I want to form the next one. That is 1. I will bring that 1, that 10. I will change this 0 to 1. You can see the sequence of the number. 1, 1, that's 11. 1, 2, that's 12. 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. Automatically, I go to the next figure here will be 2, 0. You can see. What does that mean? It means that this one here, I increase it by 1. So the 0 is changing. And it continues to change. When it goes to 9, it changes to the next one. Now let's look at, after I get to something like 91. 91. That is 9 tenths and 1. 92, 93, 94, 95, 96, 97, 98, 99. You can see, it becomes 100. You can see the font here. After I change to 100, I will come again and make it 101, etc. To millions, to anything. Any other number I form it is by combination or permutation or arrangement of all this. And I can repeat these numbers as often as possible. Now, you know the joy of fun in this is this. When you want to multiply, this 10 in 10 places, 10 times 10 is equal to 10 squared. And that is 100. So what does that mean? I just add this 0 to this 10. Add this 0 when I multiply. And in this place too, any number you multiply, all you just need to do is to make 1 0, 1 0, 1 0. Now, if combination of the numbers that we need under base 3 is going to be 0, 1, 2. Why? I cannot have 3 here again. The 3, if I should get to 3, I have already gotten to 10. Now let's see how the sequence will be like. I have 1, 2. This is 3. Because this is the number base here, I cannot write 3. I'm going to have 1, 0. You can see, this 3 here has become my 10. It has become my 10. Fine. Now let's talk about base 3. Base 3. Under base 3, the numbers we can arrange together to form our numbers are 0, 1, 2. You cannot have 3. That 3 is going to be 10 under this number base. Just like when it is generic, the number 10 as we know it is 1, 0. That is our 10. In this place too, 1, 0 will become the 10 of this 3. Now let's compare it with our generic numbers. Now, this is base 10. Please, I am putting base 10 up. So, for this one I have 1. For this one I have 2. When I get here, it will become 10. This is base 3. So, the equivalent of this one in base 10, this is the equivalent in base 3. Now, let's continue. You know, like we did in base 10, this one will increase by 1 when it gets down. So, this is 10, 10, 10. So, this one will now become 1, 1, 1, 2. The next one is 2, 0. You can see. You can see now. I will now continue here again. I'm going to have 2, 1, 2, 2, 3, 0. And that is supposed to become my 100 here. You can see. Very easy, very fun, entertaining. Now, I'm going to have 1, 0, 1. 1, 0, 2. And this one will now become 1, 1, 0. If you look at all these ones that are in tens under this base 3, they are the multiples of 3. They are the multiples of 3. Just like the 10, 20, and whatever, they are the multiples of 10 under our denary system. So these ones are the multiples of 3, or the multiples of 10 under base 3. You can see. So that's why we have 12, 9, 6, 3. So you can see, if I want to have this one now under base 3, you can see 3 in base 10 is equal to 10 in base 3. Then I can now say that 9 in base 10 is equal to 3 times 3. And that will become 10 times 10, which is equal to 100. So you can see here. You can see here. So that is how it is. It's fun when you get to this. I have told you about the arrangement. I have told you the multiples in tens. So when you are multiplying, like here now, if I want to multiply, let's say, this 5, 1, 2, 5 in 10, times 3 in 10, it will become 1, 2, base 3, times 10, base 3. And you can see that will be 1, 2, 0. And you can see this is 15 base 10. So if I continue this, you will see. Let's try. This is 13, 14, 15. So what will this one do? 1, 1, 1, base 3. 1, 1, 2, base 3. 1, 2, 0. You can see. So I like you to form this table for different number bases, like 5, 6, 7, 8, 9, 10. Do it for as long as possible, and you will see. The conversion from one base to another will become easy and fun to you, but there is a system we are going to get there. Now, let's look at base 7, just for, comprehension sake. Now, let's quickly talk about base 7. When you have base 7, the numbers you can combine are 1, 2, 3, 4, 5, and 6. These are the numbers that we can arrange. Now, all these ones are written, they are base 10. Let's see what it will be in base 7. Why am I doing this? So that you can see how it's applicable in our weeks, calculation of weeks and days. Look at this. We have 1 base 7, 2 base 7, 3 base 7, 4, 5, 6, and then when we get here, it becomes 10 base 7. So here is 11, 12 base 7, 13 base 7, 14 base 7, 15 base 7, 16 base 7, 16 base 7, and then we have 20 base 7. When you get here, it's going to be 21 base 7. So as I said, do it for all numbers that you can do, and you will see. Now you can see, I have completed the table. Look at the places of interest. 7, 14, 30, 40. You can see 50, that is 35, 60, 42, 100, 49. Look at how we get to this. 49 base 10 is equal to 7 base 10 times 7 base 10. Like I told you before. And that is going to be 10. 10 base 7 times 10 base 7. And that is equal to 100 base 7. You can see. You can see. So it makes our job easy when we can compare some places to that of 10. Now, how do I get some of these numbers? Let's say I want to convert 39 base 10 to base 7. 39 base 10 to base 7. How do we get the tens? It means that how many 7s can we get here? That's how we get the tens. And the remainder will be the supporting figure. It's just like when you have 114 in our normal binary system. You know, 114 base 10 is equal to 1. Before I go to that, let me just quickly, I'll go for space. Now let's say I want to convert, which number was I using before? Okay, let's say 39 to base 7. How many tenths of 7 can I get here? And this is how I'm going to get it. 39 divided by 7. That will give me 5. Remainder 4. You can see that this 4 is not up to 7. So it's not giving us 10. Do you understand? So this number is now going to be 54 base 7. 54 base 7. Just like if I'm saying, how do I get out of 97? 97 base 10. What does that imply? It means that, how many tens can I get here? 9. Remainder 7. You understand? And this is 9 times 10. So in the same way, this is 5 times 10 because 7 represents 10 in this case. And then remainder 4. 5 times 10 remainder 4. The same thing like this one here. 9 times 10 remainder 7. So you can see. So if you can do this comparison easily, you can easily convert from one base to the other. So I have done that of 3, I have done that of 7. You can do that of any other numbers. Now, let's talk about conversion from base 10 to other bases. As I said before, look at this number, 97. It means 9 tenths, 7 units. That is base 10. If I'm going to have 114, it means 100, 110, 4 units. So now it means that if I'm going to have this one, something like this, in base 7, let's say I have 62 base 7 and 113 base 7. It's going to be 6, 7. You know, the 7 is the 10. Please, ordinarily I ought to have written 10, but for our comprehension, let me say 6, 10 base 7. Let's put it that way. 6, 10 base 7 plus 2 units. Because it's not up to 7, it can be written like this. Or let me say this 7. So this one too will be 1, 100 base 7. Take note. 1, 10 base 7. 1, 10 base 7. And 3. You understand? I will now show you why I break it down like this. You can see that this one is 9 times 10 plus 7. 9 times 10 plus 7, which is 97. Like this. This one is 1 times 100 plus 1 times 10 plus 4, which is 140. For this one now, 6 to 7, as I have broken it down, it's going to be 6 into 100 base 7, 6 into 10 base 7 plus 2 base 7 units. And what is 7? 10 in base 7, that is 7. Now, 7 times 6, that is 42. 42 plus 2, that is 44 base 10. Please try to understand. I got this one. This one is 7 in base 10. That is how I convert to base 10. Now, you can see. In this place now, I have 113 base 7. And that is going to be 6. And 1 into 100 base 7. And what is 100 base 7? 49. Plus 1 into 10 base 7. What is 10 base 7? 7 base, that is base 10. Plus 3 base 7, that is 3. And what does that give? This one is 49 plus 7 plus 3. That is 59 base 10. Now, if I had completed that table up to this stage, up to 59, you know, I think I ended at 49. I would have gotten 103, 113 under base 7. You know, I got it to 59. That is how it is. So you can see how you can play with this from one place to the other. I will now show you the easy standard way to convert. This is just to show you the broad, you know, perception you should have when you are converting from one form to the other. So I have tried to talk about one form from base 10 to other now. Now, or from the other basis to base 10. Let's talk about from base 10 to the other number. Let's say I want to convert 17 base 10 to base 3. From what I have done the other time, you know that when we have 3 in base 3, it's going to be 10. When we have 3, 9 base 10 is going to be 3 base 10 times 3 base 10, and that is 100. If I want to work with that here, you can see I will go for this highest, I will remove it from this, and then go to this next one and continue like that until I get my final answer. See what I mean? How many 9s can I? 17 will equal to 9 plus 8. 17 will equal to 9 plus 8. So I have removed this one now. So only one 9 can I find it. This 8 now will be equal to 2 into 3 plus 2. So 17 is equal to 9 plus 2 into 3 plus 2. 2 into 3 plus 2 plus 9. So what does that mean? I have 17 base 10 will be equal to 100 plus 2 into 10 plus 2. You can see now. And these ones are base 3. So this is going to be 100 plus 20 base 3 plus 2. And that is 1, 2, 2. Simple. So if it is bigger than this, I know what number gives me 1,000. I know what number gives me 10,000. But I'm still doing it for you to just compare it. Very easy. I will now show you the easiest and the commonest way of doing it. We have treated factors and multiples before. So that is what we are going to do in this case. Just simple division. Now, under this one, you don't even need to apply all this one or think about this. All you just need to do is you put 17 here. And then you write 3 here. If I divide 17 by 3, that one brings me 5 and remains 2. If I divide this 5 by 3, it gives me 1 remains 2. Dividing this 1 by 3, I have 0 remains 1. By the time you look at it, you can see that the total division I have done here, are you getting me now? I have successfully divided this number by 9. I have successfully divided this number by 9. And that is this one. And then, this 3, I have also applied this 3 at the end of the day to get this. So you can see, I don't need this one to be able to do this. But it's just for you to know what happened. After I have divided like this, all these remainders, I will now copy it from down up. Because at this point, it has told me that I have already divided by 9. So this is the highest. This is the remainder from the highest factor that I used to divide. So lesser one and then lesser one. So here I divided by 3. I got this. Here I have divided by 9. I got this. But I was not able to divide by 3 successfully. That's why I have 0 here. So please take that one. So at the end of the day, the answer is going to be 1, 2, 2, base 3. That's how you convert from base 10 to base 3. From base 10 to any other base, that is how you do it. From base 10 to any other base, that is how you do it. Now, let us now convert from this base 3 back to base 10. From base 3 back to base 10. So, what am I going to have? I'm going to have 1 times 3 plus 2 times 3 plus 2 times 3. Remember, like we did before, this is ordinary units. So this is 0. This is 10. So this is 1. This is 100. This is raised to power 2. Remember from this place. Because this is, the last one is units. So this is 3 here, will be raised to power 0. I would have started writing it from here, but it's good to write it from here, so that there won't be confusion. 2 times 3 raised to power 0. 2 times 3 raised to power 1. 1 times 3 raised to power 2. You can see. So I have units, tens, and hundreds. You can see. So what do I have? I have 9 here, plus 2 times 3, 6, plus 2. And that is 17. So you can see. Very easy. Just work on this thing. Form that table. I always encourage my students to form that table for different bases. And then when you are doing this, you will just make gain of converting from base 10 to other bases, and from other bases to base 10. Simple. Now, I would like to show you another way of doing this. When we did 17, let's see how we got it. And let's see if there's any other thing we can do, any other way we can look at it. I got 5 here, 1 here, what do I have? 3 and 2. 3 here, 0, 1. Now, if you look at it, from here to this place, I got 1, 2, 2, is 3. How? From this, what is the process I used? I divided by 3, got, what's it called? 5, remainder 2. I divided this again, got 1. Now, let us do the reversal of the process. Let's multiply. So, let's do it like this. It means that I'm going to have 1 times 3. 1 times 3. And what does that give me? It gives me 3. You know, here I subtracted. Remember, divided, subtract. Got the answer? Subtracted. Let me now add these 2. Just showing you what I did. When I added these 2, I got 5. Multiply again by 3, I got 15. Again by 2, I add 2, I got 17. Let me now make it represent it better in a better diagrammatic format. I'm going to have 1 times 3, that gives me 3. Now I have 1 to 2. Now I will now add this to this 2. It's going to be 3 plus 2, and that is 5. This 5 now, I will now multiply by 3. You can see. When I multiply by 3, what do I have? Sorry. By 3, I have 15. So this 15 now, I will now add it to 2. Can you see? So you can use this format as well. It's the same thing like the other one. It's just like I'm not using powers here. The powers are taken care of by continuous multiplication. By continuous multiplication, the powers are taken care of. So you can easily move from one base to the other, from base 10 especially to another base. Now if I have a number in base 7, as I was saying, if I have a number in base 7, and you have to convert it to base 9. The easiest thing to do is to first of all convert from base 7 to base 10. And then you now convert from base 10 to base 9. And the same way, if it is from base 9 to base 7, let's see, base 9 to base 7. You have to convert from base 9 first to base 10. And then convert from base 10 to base 7. This is the general way of handling it. This is the general way of handling it. Now, I have shown you how to convert from one base to base 10 and from base 10 to that other base. I want us to also talk about the decimal under number basis. The decimals under number basis.